All right. Welcome to our GMAT Club workshop. I'm Dmirty Farber from MPrep. This will be the first of 3 sessions on reading comprehension. Ours is going to be on science. Episode 2 is on May 20th, and episode 3 is on June 10th. But today I'm here to help you handle the reading comprehension around science. Um, to some extent, of course, every reading comprehension passage is the same. The approach is the same because we just want to read the text. We just want to understand the question and answer it. But science can pose some unique strategies in that many of us find the content very intimidating. And I'm curious for those of you visiting if science is kind of a scarier side of it or more comfortable side. This really varies from person to person. But love to hear your thoughts. Is science the worst? Is there a kind of science passage that drives you crazy? Or does it really just depend on how you feel about the comments? I see a lot of variation there. But the main thing I want to make sure that we're all comfortable with is that there's a process you can use for reading comprehension, whether it's about science or whether it's about history or anything else, that will make it easier to handle whatever question they throw at you. And that it does not require you to have a thorough grounding in the background material. You don't need to be a physicist. You don't need to be a biologist, right? You don't need to be a doctor. Um, it's all about the amount of detail that individual questions require and finding those details in the text. Yeah, comment biology is particularly challenging. Yeah, a lot of people find that so. And sometimes I find that people find the content challenging, even if it's their personal background. I'll see someone who says, I was a biochemist, and this biochemistry passage is driving me crazy. Right? Yeah, for other people, the humanities are much worse. I'm not a scientist. I come from a humanities background. Technically, I have a master's in science, but it's education. So I'm not an engineer. I'm not a physicist. I'm not a biologist. I've never even taken a chemistry class in my life. And yet somehow I can get into a passage about those things and get them right. And that's what I'm going to try to show you today. How do we get them right, even when we don't have that strong content background? Okay. So reading comprehension on the GMAT focus these days, it's roughly half of your exam. What you'll typically see is between 3 to 4 passages with about 3 or 4 questions each. So at the minimum, you can give yourself a couple minutes to read. I will often take more. It wouldn't be uncommon that I'm going to take a total of 3 to 4 minutes to finish the first question, which means maybe I'll take 3 minutes to read the passage, and another minute to read the question, somewhere in that neighborhood. And although time is definitely a concern, I wouldn't want anyone rushing through their comprehension of the passage to get to the questions if they're then going to miss all the questions. So it's definitely a balance to strike. But this would be the rough idea. For the kind of passages that we're going to do today, not only are they science passages, they're on the long side. Definitely taking more than 2 minutes might actually be advisable. Right? So we're going to get into science today. Next topics will be business. That's the May 20th one, and humanities or social science for the June 10th one. But today, science, we're going to get technical. Want to make sure we're feeling okay. So we're going to talk about how to map out your passage. We're going to talk about our 4-step process for answering reading comp questions, and we're going to look at varieties of questions, different styles of questions, and what they require of us. I think probably the biggest misconception people have about these questions in general is that we're just supposed to read the question and just see which answer looks good. This often leads to a sort of associative thinking, almost like the way a search algorithm might work. I'm just looking for something that kind of sounds like what they're talking about. Instead of, I know exactly what the question is asking for. I know what kind of answer I want, and I'm looking for an answer that does precisely that. So big goals when I'm reading a passage. I want to know the message of the text, but this is really in service of understanding purpose. So I really think of this triangle from the bottom up. I want to know the author's point in writing this passage. So for a science passage, maybe they are supporting a theory. Maybe they are explaining how something works. Maybe they are talking about a controversy or an unsolved question in science. They're giving us that main idea. Then we want to know how each paragraph supports that purpose. They might say in paragraph 1, introduce a theory. Paragraph 2 show the support for the theory, and paragraph 3 show applications of the theory. Right? Um, the basic message of each individual bit of text is not something I have to have. So you could think about it as the bottom two things are things that I must have. The top thing is something to help me to support me in getting those other two elements. But it's not something I have to understand for every single line. It is common and quite likely that there will be parts of this passage. If we're reading a dense text about physics or about biochemistry, there are going to be some concepts that either we don't understand or we don't feel we have the time to delve into and understand, right? It might be something that we could understand if we're given enough time. Sometimes it's something that we won't understand. I'll have students who will tell me, and I felt this myself, that I might take 10 minutes on a part and not fully be confident that I understand what it's talking about. So it's okay to let some of those things go. I want to get the big picture. Okay. With that in mind, I'm going to give you a passage. Um, Curious, looking at this passage, giving it a glance, how long do you think you would need to read it? I often find that people rush this part of it, but every now and then I have folks who are just, give me more time, give me more time, give me more time. So I want to balance that today, and I want to give you 3 minutes to read this passage. Um, it's enough time, hopefully, to get a decent take on a sentence by sentence level from this passage, although it's going to depend on your comfort with reading this kind of material. Um, but it's not enough time, maybe, to get all the details fully thought about and noted. Right. So definitely think about, am I going to take some notes as I read this? Or am I just going to try to read it, freestyle? I'm somewhat neutral on that. But most people find that taking a few notes supports their process of understanding the passage. So I'm going to be quiet and give you 3 minutes to read this passage, and then we're going to come in and discuss it and try some questions. Okay, 3 minutes. Here we go. All right, there's your 3 minutes. Curious how it went. Did that feel like adequate time to make sense of this passage? Um, that's going to be personal, of course, but it also depends on what we mean by make sense of. So, at this point, do you feel great about what a PN junction is, right? Um, do you get all that stuff about coiled or uncoiled crystals? Um, are you sure about the benefits of LCD monitors, right? That's a lot to think about in a short amount of time. I don't have to have all of it. What I want to have is a loose map of the passage and a general idea of the author's overall point. And if you have that, you have enough to start answering the questions. So what I'll basically do is I'll run through, and I'm neutral in terms of this about whether I want to uh, write all this down, like I said, or not. I personally, and you'll find a lot of teachers are like this. A lot of teachers don't write a lot of notes. And so a lot of people say, oh, well, then maybe we shouldn't write notes. Maybe that's the best practice. But the problem is the people who teach this stuff tend to do it because they're really strong in this topic, right? They're really strong at this material. And when we don't feel that strength, then avoiding the notes is not always that wise. Honestly, though, even if you're really good at this, it might be because you're getting some support on your paper. And so some reason to write notes are one, keep you awake, right? You're more likely to be attentive, to not skip an entire section if you're writing some things down, to force you to rephrase and to simplify. Um, One of the mistakes people make is they want to tell you all the details. Not only are they trying to understand all of this about films of transistors and all that, but they're wanting to tell everything instead of what's the short point, right? Um, and it helps you with mapping the structure if you're writing things down because it helps you see how the pieces are fitting together. So generally, I advocate for note taking, but if you're the type who is comfortable not taking notes and it's working for you, then fine. I don't push anybody about it. So let's see if we can get this basic idea of a passage map on here. If you look at the first paragraph, we see that there's a comparison or contrast being made between LEDs and LCDs. We don't necessarily know how much they're similar and how much they're different at this point, but it says the names are similar, but they are distinct. So that sounds like a contrast. They're distinct, they're different from each other, right? Um, Now they start getting over my head scientifically pretty quickly. Maybe this is what you do for a living, and you know all about these kind of diodes, right? I don't, so I say, okay, LED stands for light emitting diodes. There's two different materials layered together. I can understand that. Okay. N type, in which mobile electrons carry negative charge, and P type, in which holes in an otherwise bound sea of electrons carry positive charge. Okay, I can't tell you much about that, honestly. So what do I need to get out of this right now? I'm needing to get that there's two layers put together. When electric current flows through the PN junction between layers, okay, so that's just sounds like a fancy way of saying flows between them. An N-type electron falling into a P-type hole releases a photon, a specifically colored particle of light. Hey, I've heard of photons. Cool, it's light. But even if I'd never heard of a photon before, it tells me it's a specifically colored particle of light. So you literally don't even need to know what a photon is or an electron to understand what we need out of this, right? Which is, hey, they're telling me how LEDs work. So if I were going to write down a short thing, I might say something like LED versus LCD, how LEDs work. If I have that much, I'm good. Okay. Second paragraph, longer, but maybe not a surprise what it's going to do. It tells us how LCDs work. So if I'm reading and paying attention, I know what the second paragraph is going to do before I see it, right? They've told me these things are different. They've told me how LEDs work pretty quickly. Now they're going to tell me the next thing, how LCDs work. And that's what they do. So they tell us what LCD stands for in case you're curious. So again, it's going to get over my head pretty quickly. They apply thin film transistors of amorphous silicon sandwiched between two glass plates. I can try to picture all that, and a lot of those words do make sense, but I'm not going to spend a lot of time on that. I'm not going to spend a lot of time on it. I don't care, really, honestly, right? I'm going to say, okay, they're applying something between a couple plates. All right. And then those things supply voltage to liquid crystal filled cells or pixels between sheets of glass. Hey, I've heard of pixels, but is that the same as like a pixel in a graphic on a screen? It sounds kind of like it. Um, Liquid crystals can twist the polarization or wave orientation of light. Wow, okay. That's a new thing, right? Okay, so they're twisting the orientation of light somehow. So I'm imagining that there's electricity going through some kind of glass transistor setup. Light is getting twisted somehow. Why do I want that? Right. So it gives me an analogy. And whenever they give you an analogy or an example, usually you want to slow down and make sure you've read what they just said, because that analogy or that example is there to support some point they have already made. So they've already said it's twisting how light is oriented. So they say, just as a guitar string can vibrate sideways or upside down, up and down, a light wave can be polarized horizontally or vertically. Um, these filters act as selective gates, transmitting light polarized one way but not the other. Okay, so it's some way when they turn this electricity on that it's able to basically block some kinds of light to get through. Okay, so within a pixel, liquid crystals in the relaxed coiled state, okay, relaxed, they rotate the polarization of ambient light enough to make surrounding filters transparent. Okay, then electrical signals uncoil the crystals, causing the filters to block light and the pixel to become opaque. So it sounds like what we have is glass that you can see through, roughly, until they apply a current to it, and now you can't. Opaque meaning that light doesn't get through. Okay. LCDs that are capable of producing color images, such as in TVs and computers, reproduce colors by blocking out particular color wavelengths from the spectrum of light until only the desired color remains. Okay, so this requires a bit of familiarity maybe with how light works, that light has a spectrum to it, right? That, the ambient light in a room, for instance, or the light from a source in your device, has got the whole rainbow in it, and it's blocking out some parts of it. But I think a lot of us are familiar with that in a rough sense. And so the variation of the light permitted to pass through enables LCD displays to present images full of gradations of different colors. So it sounds like what they're saying then is, in an LED, they're creating a particular junction that sends out a certain light particle. Okay, this is a yellow light and this is a purple light, etc. Right? Um, whereas LCD TVs are taking a light source and blocking out the unwanted parts to show you what they want you to see, whether that's just where the light is versus where the light is not, or whether that's the wavelength of light that you see, the color of light you see. So it's almost like LEDs are, to be very crude and imprecise, right? And someone who knows more about this than I do might say, no, 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 right? But again, I'm not supposed to be a science expert to get these right. So to be crude, I could say the LED is making the colored light, and the LCD is filtering until it gets the light at once. That it's blocking rather than creating. Okay, that's the difference between the two technologies. Uh, Paragraph 3. What's it going to do now? What's left? Is it going to talk about when you use each type, or whether one's better? Is it going to talk about a new type that we might have? What's it going to do? Let's see. The amount of power required to untwist the crystals to display images is much lower than that required for analogous processes using other technologies such as plasma. Okay, so it's low power. Maybe it's going to save the planet. The dense array of crystals displays images from computer sources extremely well with full color detail, no flicker. And okay, so it looks like what it's saying is advantages. The number of pixels per square inch on LCD is higher. LCD monitors are okay. So it's just great stuff about LCDs. All right, kind of a random way to end the passage. It never mentions LEDs again. And I'm starting to wonder if LEDs are even really the point. They start talking about that. They're like, hey, LEDs and LCDs are different. Here's what an LED does. But then, okay, LCDs are the big deal right now. That's what it says at the beginning of paragraph 2. Here's how LCDs work. And here's a bunch of advantages of LCDs over other things. So although they're comparing LEDs and LCDs, and an answer choice might require us to say that, it seems like the LED mention is almost a way of saying, you've probably heard these letters so much that you don't realize that they're very different. And an LCD, maybe we should have named it something cooler so it would catch your attention. An LCD is actually kind of a big deal, and it's kind of maybe a newer or more powerful thing. Okay, so again, if someone works in the industry of constructing these things, they might be laughing at my explanation. But haha, I got to get the questions right. So that's all we want. We're not trying to become content matter experts on these things. And I think one of the scariest things about science can be that feeling that we're already missing the expertise that we need to know this stuff. And sure, does it help if you understand a lot of these concepts already, if you've already heard about this, if you know about photons and electrons and polarization of light, does that help? Sure, to some extent. Um, but in the end, it doesn't matter so much what the passage is about as what your process is. Okay. Um, so let's work on the process of answering the questions now. Our basic process when we get to the questions is a 4-step one. And the idea is that we want to, um, sorry, let me get to it here. We want to identify the question. We want to find the support for our answer. We want to predict that answer, and we want to eliminate and find a match. And I want to take a minute to talk about this process because a lot of people do not do this full process. And sometimes there's something that might be described as 4 steps, but it really doesn't feel like 4 steps. It feels like 2. This, I really want it to feel like 4 different steps. And I think it's important not to skip or to understand each of the steps. So I want to take a moment here. First off, identify the question. This might seem like one of the more straightforward ones. Just read the question. What are they asking? But the idea there is to recognize the type of question that's being asked and to recognize what that's going to require of you. So some common question types would be a detailed question, just what did they say? This can feel very easy, but it's often a lot of rewording that goes on, and so we have to make sure we're matching the concept, not just the words. Inference questions. This is the most misunderstood type. People think this is something that feels like a guess or likely to be the case. And the GMAT kind of plays into this a bit sometimes because they say things like, which of these is most supported, or the author would be most likely to believe, these kinds of words. But in the end, an inference is something that you can know. Um, there might be some slight wiggle room, there might be some slight uncertainty, but essentially in an inference question, there should be one answer that's provable from the text and 4 answers that are not provable from the text, and it should be that simple. There can also be application questions where you're maybe having to use the author's perspective to see something else, analogy questions where you compare what you're seeing to a different case, strengthen or weaken questions, which will ask you to do the same thing you do in a critical reasoning question. But the majority of the GMAT is really on reading comp is really about inference in one way or another. It's what can you know? Is it a straight up detail where it's what did they tell you? Or is it one where it says suggests or implies or most likely where you're figuring something out? But either way, it's something that you're going to know. And I think the biggest mistake people make on this is they try to guess or say what just seems about right. They go with sort of associative thinking. Hey, this sounds like the kind of thing, or this seems reasonable, or this makes sense to me. That's not how to do reading comprehension. It's just not how to do it. Instead, we have to make sure we're finding very clear support in the text. So once you know what you're looking for, you're going to go back to the text. In theory, you won't even have to have read the text. You might do this in a text you haven't read. But in practice, it's going to be very hard to find the support if you haven't already read the passage and understood where everything is and what's going on. So there have been tests in the past, maybe paper and pencil tests like the SAT, where I would have students not even read the passage. The GMAT, I do not advise that. I do not advise that. So you've read the passage, you have it mapped out, that helps you find the support. Then you make a prediction. This is a step I don't want you to skip, but it's another misunderstood step. I've seen people say things like, well, you shouldn't waste your time trying to guess what the answer will say. Or there's no way to predict all the possible answers that they might come up with. Absolutely true. Absolutely true. But that doesn't change that we want to try to predict an answer. And the idea of this is we want to know what we are looking for. Sometimes it might be pretty vague. Um, if the question says each of the following is mentioned in the passage except, okay, I can't predict what the answer is going to be. The answer could be about bunny rabbits, right? I don't know. All I know is that 4 of the answers will be things that I can go find, and one of them won't. So the only prediction I can make there is I need to find something that's not in the passage. And so I can't do that directly. I need to do it by process elimination. I need to find things that are in the passage. And that's as far as I can get with prediction. Other times, if you think about, say, the way we weaken an argument at critical reasoning, let's say you're doing a similar thing in reading comp, you're weakening a perspective, then you might be looking for something to undermine a particular point. Right? You're saying, oh, the author thinks this because of X. So if X didn't mean Y, then, it would fall down. So I need something to say, this isn't going to work out. And I don't have to know exactly what it's going to be. Right. I don't have to know that. I just need to know, say a problem or disadvantage, right? Maybe something will be too expensive to implement, or maybe something will take too long to fit the time frame that they have suggested, so it's not going to work out. But on a detail and inference question, which is where we're going to spend the majority of our time, usually you can do a better prediction than that because you can actually answer the question in your own words. If they ask you, what is this, or why does this happen, or where was this, or you know, how is this stage different from that stage, right? Usually you can have an actual precise answer, and I want you to try to do that. From there, then we eliminate. And ideally, if we predicted well, it feels very much like no, 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 that one. Yes, yes, exactly. But it doesn't always feel that nice. Sometimes we get down to two and we're back and forth. Um, Sometimes we don't see any answers that look good because the thing we predicted either was wrong or just didn't quite match the way they phrased it in the answers. So we'll have to fine tune those steps, but that's the underlying idea. So let's do a question. Um, the first question is a vocabulary and context question. And so this could seem like it's asking about the meaning of the word. To some extent, it is. If you didn't know the word otherwise, that could get in the way. Um, but it's really a kind of inference question because they're asking about purpose. And so those final three words, in order to, are extremely important. The author uses the word otherwise, in order to. We're saying, okay, not just what does that word mean, but why are they saying it at this time? And so I'm going to have to go back to the text. Now, thankfully, sometimes they'll ask you about a part that they just highlight for you. So you don't need a passage map. And in fact, if I ever dropped into the middle of someone else's GMAT and said, go, answer this question, I would not need to read this whole passage to understand because I just have to look at the immediate context. So what's the immediate context? They're talking about how LEDs work. They say some different materials are layered together, N-type and P-type. And then they say holes in an otherwise bound sea of electrons carry positive charge. Okay. Holes in an otherwise bound sea of electrons. Okay. So if the sea of electrons is otherwise bound, what does that tell you about these holes? Holes in otherwise normally means in any other case, right? If I said something like, does anyone have any questions? Otherwise, we'll move on. The idea is in any case where someone doesn't have questions, we keep going. So when I say otherwise bound, that's saying that if something's not one of those holes, it's bound, it's fixed in place. And so my prediction here is to say that they're emphasizing that these holes are the only part of it that's not fixed in place. The holes are not bound, they are free. And with that in mind, I'm just going to look for an answer that says something along those lines. Maybe it'll say it pretty precisely. Maybe it won't quite match my prediction, but this is what I'm looking for. Um, so go ahead and take a moment to look for it. See what you can find. You're probably noticing that it gets pretty technical, right? Talk about the N-type versus the P-type, the charge carriers, foreshadowing the results of the electron hole encounter, right? But as some of you are coming up with your answers, you're not getting drawn into those super technical pieces, right? We know that the holes can move. They're mobile. Mobile means it can move. The answer is A. And so that's the really important kind of pre-work we can do to save ourselves some trouble. Now, you could look at B and say, well, hey, that says mobile electrons too, but that's talking about in two different layers. The mobile are in one type and the bound are in another type. And instead, what they said is that within that P type, there are bound and unbound, right? So it's within the P type. If we needed to verify that, we could, right? Okay. So that's the idea. Let's try a longer question. So this one is asking for something totally different. It's asking for an analogy. The process through which an LCD monitor displays different colors is most closely analogous to. Mhm. Yeah, and I'm watching the clock, and so I am giving people time to guess on their own. But on some of the questions, I'll go pretty fast because the GMAT, it moves, and so definitely I'll give you a heads up for future questions to commit to an answer, even if you're feeling like you're rushing me. I don't have time. Get used to committing to it at that point, and then I'll give the reveal. Okay. So for this one, I actually do want to have you try it. On your own without my prediction. Um, so here they're asking for an analogy. So they're asking, hey, how is an LCD monitor's display working? And then what else would work in that same way? So you're going to need to make sure you go back, have that understanding of how the LCD display works, at least in rough sense, and then work to compare it. Once we have that, then we'll talk about how we might have predicted that well. But take a moment to try this on your own. I'll give you about a minute. Okay, so take a moment to commit to an answer, even if you feel like you would like more time. So if you're in the chat, you can definitely drop it into the chat, or at the very least, just commit to it in your mind or write it down. So you're saying, okay, I'm picking one. Um, Okay, so analogy questions can get a little tricky. And when it's analogy to science we don't fully understand, that can be especially tough. I might think, hey, I barely understand the first case, and now you want me to compare it to something else. But analogies can also be a way of clarifying understanding of the original concept, right? And so if we go back to the text a little bit and say, okay, what were they saying about how it shows different colors? Let me go to that part. Oh, that was near the end. It says LCDs that are capable of producing color images reproduce colors by blocking out particular color wavelengths from the spectrum until only the desired color remains. So it feels, even though I'm sure it's fancier than this, it feels kind of like a filter, right? And I don't mean a filter like an Instagram filter. I mean an actual piece of glass or plastic you'd put over a lens, right? All I'd have to do if I wanted to look, green, is take a piece of green plastic and put it in front of my light source, right? And that would create a filter on how I appeared, right? And so it sounds like it's working like a filter in that it's letting some light through and not other light through. And so I need an answer that says something about allowing something and allowing only what we want to get through, right? And blocking other things. Okay. So if I look at A, the partial blocking, hey, that sounds promising. B, the use of rigid sizing boxes in an airport in order to allow certain size. Okay, so that's something about something getting through as well. That's also possible. C, the soundproofing of recording studios so that any performances within are muted to those outside. Now that doesn't sound promising. What's the problem with C? It sounds like we're not letting anything out, right? That would sound like the TV is not on, right? The TV is not allowing any light to show, right? Or at least the screen is not lit up, right? I don't want that. Um, D, the cutting out of characters from a sheet of paper said that a lamp in front of the paper casts shadows. That's interesting. Sometimes I've kind of gone in circles with this of like, wait, are you saying that I have a character like a letter or a person, and it's blocking the light, and so um, that's where you see a shadow? Or are you saying I'm cutting out of a piece of paper so that there's an empty part and the light gets through, but then it wouldn't be a shadow. But in the end, I actually don't care which one it is. I don't even care whether D is saying that I have a piece of paper like shaped like a man and then it leaves a shadow, in the light, or whether I'm saying I have a cutout of the man in the piece of paper and you see his shape and the rest is dark. Because either way, what's happening there, it's not filtering. It's blocking light in one place and allowing light in another place. And that's not how they're creating color. Even if it turned out when I looked back that that was how they created light in general, the question's asking about color. And that wouldn't be about color. That would be here's the light, here's no light. So D is out. Um, E is what? Air conditioning and cooling. No, that sounds like um, we're just moving something from one place to another, right? Um, we're pumping the cool air in, we're pumping the warm air out. I don't see how that would be analogous to light. We're taking light from one place and putting it somewhere else. That's not giving me what I want. So it's got to be A or B. So really common that we get stuck between two. And one common thing that people do is they just decide which of those two is better. I think that's a mistake. It's not that one of these is better, one of these is right, and the other is wrong. And I think it's very important to buy into that concept that one is right and the other is wrong. So that means that one of them must be doing what we want and the other is not somehow. So let's check this again. We want something that blocks undesired elements. I see blocking and I see allowing, excluding. Okay, that seems to be there in both A and B. So that only what we want gets through. Well, now wait a minute. If I look at the airport, I could say, oh, we're excluding some luggage, but we're allowing the passage of other sizes of luggage. That's a fit. A is only just limiting the flow, right? So if you think about the partially blocking of an hourglass, has this kind of shape, right? The sand is coming through. And if I put a little bit of wax or something in that juncture, that means the sand is going to travel more slowly. We're going to get a thinner stream. We're going to get less. So, right. So A is just describing, if you think about it in terms of light, blocking or attenuating the light source so that there's less of it. But it's not talking about filtering it or allowing some kinds of light through, right? A is not talking about, hey, these kinds of grains reach the bottom and these kind don't. If I partially block the hourglass and all the sand is the same, then all the sand gets to the bottom eventually. It just takes a long time. If there are different size of grains of sand, that would be interesting, but they never say that, right? Plus, that analogy gets complicated. If there are large grains of sand that can't get through, would they simply block the passageway so the others can't get through? This is where we can get into the zone that a lot of my students describe as overthinking. I'm not crazy about that word because I think often what we're really doing is just we're not clear on our task, and so I think the antidote to going in circles on a question is to clarify the task. So I want something where I'm blocking one kind of thing, but I'm letting only certain other things get through. I'm not simply blocking so that less gets through. So A is just talking about limiting the stream. A is wrong. B is talking about filtering the stream so that some things get through and others don't. B is the answer. We all right with that? Questions? I know this one was a little trickier for some folks than the last one, so curious if you have any questions or thoughts on that. Okay. Sure. All right. Glad to help. Yeah. Yeah, and if anyone, if you're enjoying the session, obviously, I'll say all the social media stuff, like, share, subscribe, right? But we'd love to see you in our future sessions. I don't know offhand who the teachers are for those two. It won't be me, but our teachers are pretty cool people. So the second on May 20th and the third on June 10th. Um, let's hit a couple more questions. Make sure we're getting this, and I want to, keep with the science theme. I want to make sure that we're thinking about how we deal with this technical detail. And so notice that again, we had to grapple with the science a little bit to answer this, but we did not have to become scientists. And that's really important, right? Let's take it even further. I'm going to give you only 30 seconds to answer this one. It's not really a science question at all. 30 seconds just to get the feel of this. Okay, let's have those answers. 30 seconds is not a lot of time, but that's how long I would take on a question like this typically. Um, because by then I've already read the passage pretty thoroughly. I've analyzed. I just want to predict what kind of approach the author is taking. Now, does that mean everyone's getting this right? No, I'm seeing a pretty wide range of answers actually, and so we do want to fine tune how we do these. And sometimes when we do go fast on a question, sometimes we think of it as a little too simple or easy, or we just go with whatever feels right to us. This is the kind of question that most used to bother me when I was younger, because I always felt it was a matter of opinion. Well, they think the tone is described this way, and I think it's described that way. It would be like if the question said, what's the best kind of dessert? You said, well, to me, it's chocolate, but someone else went, no, no, it's not like that. There has to be some way we can have a definitive answer to this, right? So first off, I want to predict. I don't want to just look at the answers right away because that's going to mess with my mind. It's going to give me unnecessary ideas that are going to distract me. Instead, I want to say, okay, tone. Tone typically applies a couple things. One, um, positivity or negativity versus neutrality. Like, is someone supporting or advocating something? Is someone attacking something or pulling it down? Or is someone just neutral describing? The second would be the style or emotional content of what they're doing. Um, I could say that something's bad, but I could say it in a very bland, calm, scientific way, or I could be saying how terrible and it is, and I could be very emotional about it or very angry, right? The GMAT doesn't tend to go in that direction, right? You're not going to see really like imagine if they got into really heavy issues about politics and religion and morality, and it might be upsetting even to read about, or you might harshly disagree with the author. They don't tend to do this, right? But the authors can have opinions. And they can be, for instance, supporting their own ideas. They can be saying, hey, this is something I have done or I have researched and I want you to believe it. Or they could just be presenting it kind of more like, hey, here's the thing. It seems kind of cool, but make of it what you will. It would be like if you heard about a business and it's not your business, and you don't have any financial stake in it and you haven't tried much of it yourself. You might just say, hey, I heard there's this company doing this thing. It sounds kind of interesting. And then if someone told you actually it didn't work or it was bad or unethical, maybe you'd change your mind very quickly. You're just reporting it like, hey, I saw this thing. It seems like it might be good, but I don't have a strong opinion about it. Versus this is going to change the world and this is the best way to do things. So the kind of opinion they have, positive, negative, neutral, the strength of that opinion, and the way they feel about it are kind of what we're looking for. So here, what we can see is they compare LEDs and LCDs. They spend most of the time on LCDs, and they're positive about LCDs. LCDs seem good, right? But they're not saying you must use LCDs. They don't care what you do, right? They don't seem to have anything to gain from one side or the other. And there's not really an argument. It's not like it's LEDs versus LCDs. So there's not a really strong matter of opinion here. So what we could basically then say is they're trying to spend most of their time just telling us how the science works. And they are mildly positive toward the LCD technology that they spend most of the time on. Can we agree on those things? If we can, then there are a couple things we can get rid of, right? Um, One is supportive advocacy. I want to get rid of A because they're not advocating for the use of one particular thing. They gave us some advantages of LCDs, but that's very different from saying you ought to use them, right? That's very different. They're saying LCDs are better in some ways than some other technologies, but they haven't said at any point that this is something that needs to happen or that there couldn't be a better thing to come along tomorrow. Right? So they're not spending most of their time uh, telling us what to do. Okay. So I'd get rid of A. Um, I'd get rid of E for a related reason. They're, again, not spending a lot of time supporting anything. They're spending most of their time telling us information. But the other funny thing about E I thought was worth mentioning, because I've seen it on a few GMAT questions, is the use of the word qualified. You might read that if you hadn't seen that usage before and think that just means the author is supporting something and they're qualified to do so because they clearly understand the science. That's not what it means at all. When you qualify your support, it means you put an asterisk on it. It means you say, well, except or unless or only in these cases, right? It would be like if you if you gave me a recommendation, you said, oh, you know, Dmitry is a helpful tutor as long as you don't mind the goat staring at you in the background, right? You're saying, look, if the goat creeps you out, you might not want to work with Dmitry, right? And so that's adding a limitation. And so E would only be right if the author was saying, first off, yes, use LCDs, but second, use them, but only in some cases. And we could try to support that answer with the paragraph, because they are talking about the uses for which LCDs are good. But if we can agree then that the author is spending most of their time and most of their energy on not telling you to use LCDs at all, but simply telling you about how they work, then we won't choose A or E, regardless, whether it's just being supportive or being supportive with some limitations. Okay. So that gets rid of A and E. B, historical discussion. No, no, I didn't see a lot of love for that one. They're not giving us the history. They could have, they didn't, right? Okay, so it leaves us with C and D, objective explanation and intellectual exploration. Gosh, what's the difference between those things? They're both more just talking about the science, right? Um, but I think here we could just go with, there's no reason for objective explanation to be wrong. I'm going to go with C. First off, are they explaining? Absolutely. Informational means they're explaining. Are they objective? Well, you might say they seem to think LCDs are an advance, right? But notice they never actually say that LCDs are better than LEDs. And they never seem to have a stake in the matter. They're never saying, here's why my LCD invention is the best. They're just kind of telling you what they think. And in that sense, it's fairly objective, and maybe telling you what you think they think is not the right phrasing. They're giving you some information, and not focusing too much on their own particular opinions. Okay, intellectual exploration is too wide ranging. That would imply that um, they're really thinking about a wide range of ideas. And here, really, they're very tightly focused on one thing, and they're just telling you. They're not saying, "Imagine this," and "What if electrons were actually positively charged?" and "What about this?" They're not doing any of that. They're not playing with the material, and they're not really grappling so much with um, conceptual stuff as they are just saying how two different systems work. Okay, so that's going to be just a straightforward explanation, and C is going to be our answer. Okay, let's hit one more question on this passage. Um, we had to grapple at some point with some very specific science. We've seen a bit of this already, but now a little more. What can we infer? And again, remember, infer means know. What can we know about uncoiled liquid crystals in an LCD pixel? So make sure for this one, you're going back and saying, okay, uncoiled. Right? What do we know about those? And it's not just going to say the words. We have to put it together and figure out what's happening. When the liquid crystals are uncoiled, what is going on? Read that section, predict what's going on before you get the answers, and you're much more likely to get this right. Okay, take a moment to do this one. Okay, let's go ahead and put in our answers, even if you're not 100% sure. Um, so yeah, So yeah, you're seeing something. Okay, yeah, they're talking about whether they're relaxed or not. We got to watch that distinction, right? So let's go back to the relevant text. We're back in the second paragraph, and maybe it's not surprising that a lot of our work has been in the second paragraph because LCDs have really been the focus, and the second paragraph is the one that tells us how LCDs work. It's the scientific heart of the passage, right? So, what do we know about uncoiled liquid crystals? Well, they say that in their natural coiled state, right? When a pixel within a pixel, liquid crystals in the relaxed coiled state, right, right here, rotate the polarization enough to make surrounding filters transparent. So what can I say? The coiled ones are relaxed, and they rotate the light, and they make the area transparent. So what does that say about the uncoiled ones? They must not do that. You apply the electrical signal, they're uncoiled, and they block the light, right? Which means they must not rotate the light enough to make it transparent. So we can sort of, this is one where I think mapping it out can really make a difference, right? I might say, okay, so relaxed is coiled. The relaxed coiled ones are going to rotate the polarization of the light. That's going to make them transparent. What happens when I change things? I add electricity. Now they're uncoiled. They don't rotate. They're opaque. So I want the ones in that second category. I want the ones that don't rotate and are opaque. Okay. Um, and so now I'm going to be much happier going to these answer choices. Electric currents cause them to release photons. No, that wasn't mentioned. If I got turned around and looked at the part about LEDs, I might have chosen this, right? But that A is about LEDs. B, they're in a relaxed state in comparison to their high energy coiled state. Trap, right? They're not relaxed. That's the other version, right? That's the relaxed state is the coiled one, right? C, they're found in one of two wave orientations, horizontal or vertical. That's light itself, right? And they do talk about this concept, right? But that's not the case for the uncoiled crystals. Even if it turned out that they had those two states, you'd expect them to be in one or the other. D, they fail. Fail is such a funny word for a crystal, right? How does a crystal fail, right? It seems like failure is a more human term, right? But okay, they fail to rotate the polarization of surrounding photons enough to allow them to pass through nearby filters. What does that mean? All that's saying is fail is a negative word, right? They don't rotate. Okay, that fits. They don't allow the photons through. Oh, they block the light. And this is one way that GMAT hides answers, is it words them in ways that are less obvious, less clear. Instead of saying something like, I'm older than my brother, which is maybe what the text says, the answer says, I have one or more siblings who are less advanced in years than I am, right? They flip it around, they use different wording to say the exact same idea, right? Yes, if I'm older than my brother, then yes, I have one or more siblings who are less advanced in years than I am, right? And that vagueness can often get in the way too. But this isn't vague, right? D isn't vague. It's simply saying it in another way. And then E, they cause the pixel to become transparent. Well, no, we want opaque. Okay. So D is our answer. All right. So did we all suddenly become, graduate, scientists? Did we suddenly, get expertise we didn't previously have in display technologies and electrical engineering and the optics of light? No, we didn't. We didn't do that. And you may still feel like that's what I would need in order to get these right. But I hope I've convinced you, at least to some extent, that whether you're an English major like me, or whether you did study a lot of science, that it's not about the science itself, right? If we're about the science itself, we'd be in trouble, because even if you were a PhD, scientist, your field is one thing and you don't study this other thing, right? It never ends, right? People like Einstein still needed help, outside of their particular expertise, right? And so we can't be expected to know all these things. It has to be about process. And I hope I've convinced you a bit of that today, that we can take a process, and that also the answers are more or less objectively correct. And I think that's a really important thing to accept. So a couple things: if we get better at stopping and predicting, if we get better before that point at knowing exactly what the question is asking of us, um, and if we get away from the idea of associative reasoning. If I'm simply going to look at a passage and then grab a question and say, what feels right? What kind of thing are they saying? What's in the right direction? That's not going to be it, right? This is how we reason a lot of times in real life. We reason associatively, and we reason statistically. This is a sentence where things like stereotypes and prejudices come from. Maybe, I know a lot of people who are a certain way, and I judge you based on that. And I may be wrong, but maybe statistically I was likely to be right, and so I did that quick shorthand. um, and in real life that could be a problem too. I can treat people incorrectly because I'm making assumptions, right? But we evolve those kind of tendencies because it works out in general. If I'm looking for sources of danger, if I'm looking for sources of food, I reason generally associatively statistically. um, on the GMAT, I need to be much more precise and say, what is this question exactly asking? What kind of answer do I want to get? And what makes this answer that precise question and these other four not? So the last thing I'll say about that process is that review becomes incredibly important, right? If you can get in the habit of reviewing really thoroughly, um, then you will know, for future questions, how to be more precise in your answers. And so I'm always going back and saying, okay, I was down to two, or I missed this question, or this one took me too long. So how could I have known sooner where I was looking? How could I have predicted better what I was looking for? How could I have known that this answer was right and that answer was wrong? And those things are incredibly important to continue doing. I always tell people that it's totally normal to spend 3, 4, 5 times as long reviewing a question as you spent doing it in the first place. And if later on you want to watch this video again and run through the questions in more detail and give yourself more time, I encourage you to do that. That's where we really learn. That's where we get better. And you should see me every time I do a practice set or take a practice test. I'm spending hours obsessing on little differences and how could I have done it this way, and whether it's math, did I estimate or did I do algebra? And so for reading comp, especially for a science passage, it's, did I understand enough or did I spend too much time trying to understand all the details? Um, and then where do I look for those pieces of support, and what's the exact difference between these, and how can I get it without having to look up any more words or learn any more concepts? How could I have gotten it with what I already knew at the time? Okay. So let me toss a couple last things up here. If you want to check out our website, you can get a free starter kit for the GMAT or other tests that you're taking. We also have made our entire Foundations of Math curriculum free for everyone. So that's something you can check out if you're needing a math boost. I'll also remind you that we have our upcoming reading comp sessions on May 20th and June 10th. Thank you so much for coming. As a little extra thank you, here's a coupon code for any course. And we'd love to have you, as always, like, share, subscribe, all the great actions to keep these workshops coming. Stick around if you have questions from me, but I'm going to stop there and thank you all so much for attending today. Hope this was helpful.